You want to see if you can let u be some function. When differentiated, it gets simpler. I prefer short division maybe. There's something called short division. I can show you quickly. So we take the critical value -2 instead of +2. So we do 81, 52, -2, 20. And then we bring this down, 81. -2 multiply 81, we get -162. But we add instead of subtract. So that's it. This is lambda +2 and 81 lambda -110. Construct the chain rule equation linking all the variables together. dA by d, the other parameter, which is time, times dt by d theta. That is the easiest way to come up with a chain rule equation. We need to do maybe subtraction method. So we do the big rectangle subtracted by this cutout, like the area underneath the curve, to get that area r, right? So just visualize that, just to make sure you know what you're doing, guys. Again, be careful in binomial. When the first term is not 1, you need to do some factorizing. And don't forget to put the power into that factor you take out as well. That is usually forgotten from my experience. The key here is don't forget to change the bounds. Because I've seen quite often people forget to change the bounds, and then they, instead of the bounds for u, they have the bounds for x, and then you might be losing 2 or 3 marks. Hi, it's me again, Krubase. Today I'm gonna walk through another unseen paper. Now this time it is very special because I am aiming to get 100%. So let's see if I can do it. You can use chapter in the description to jump to any other question you want. But you know, stick around. You might pick up something useful. Are you ready? Okay, I've hit the timer. Let's crack some eggs. Question 1, integration. Alright, so integrate x cos 3x. Now guys, when you have two functions multiplied in the integrand like this, maybe think of something not so ordinary, like by parts or substitution in P4. But, you know, if you want to choose between substitution and by parts, maybe try by parts first, because you want to see if you can let u be some function. When differentiated, it gets simpler. So in this case, I'm talking about by parts here. So number 1, I'm going to do it as by parts. So I'm going to let u be x. And you can see if we integrate u, right, we're going to get, so if I do du by dx here, I'm going to get 1. Yeah. And the other one should be dv by dx. So that should be cos x. No, 3x, right? Okay. And in order to get v, you need to integrate that. So integrate a cos 3x, you would get a sine 3x without the minus sign. So integrate, you get a sine 3x. So differentiate sine, you get cos. That means integrate cos, you'll get back to sine without the minus sign. But don't forget to do a reverse chain rule here, because inside the angle expression, you have a 3x there, right? So you need to bring 3 down in order to satisfy the reverse chain rule. And if you try differentiate v back, you're gonna get cos 3x there, right? You can try check that. Now by parts, right? So we're gonna do, okay, so I'm just gonna write here first, integral x cos 3x dx with the bounds of 0 to pi over 6. It will now be equal to uv, right? Okay. So uv, so the formula is integrating by parts, we get uv minus integral udv. Sorry, vdu, right? So uv is just x times sine 3x over 3 minus integrate again with the same bounds, but I don't forget to put the bounds here as well, because those two are already the integrals, right? And then v du. So du is just 1, so we have sine only the v here. Okay, so only the v here, sine 3x over 3 dx, right? So that is just using by parts there. Okay, so next line I'm just going to integrate now, because I'm getting, so here if I substitute the bounds in there, 0 will make everything goes away. but the pi over 6 there will be just the thing we need to substitute and get the right number there. So pi over 6 substituted in x, I get pi over 6 multiplied. Pi over 6 substituted in the x in the sine 3x, so I get sine of pi over 2, and that is 1, so this is pi over 6 multiplied 1 over 3. Alright, I'm just checking there. Yeah, I'm happy with that. And 0 will make everything go away. Right, so in this integration, so we are integrating sine 3x this time. Now integrating sine, we should get a minus cos, because differentiating cos, we get a minus sign. So integrating sine should get a minus cos, so we have a minus sign here. So a minus cos, and then we get a minus cos, and if you also consider the minus sign outside the integrand, we have a plus then, because there's two minuses now. So we get a cos 3x, and another reverse chain rule would have to divide into the whole thing by 3, and that would make the denominator here become 6. Sorry, 9, because 3 times 3 should be 9. Substituting the bounds in as well should be that. Alright, so we're just gonna answer in simplest form. We're just gonna simplify everything, so that is pi over 18. So substituting pi over 6 into the cos 3x, we get cos pi over 2. Cos pi over 2 seems to be 0, so everything's 0 there. But then we get a minus here when we substitute 0 in. So cos 0 is 1, so that should be minus 1 over 9. So this is just basically pi over 18 minus 1 over 9 as my answer there. Alright, so that's the answer to the first one. First question. Number 2. Alright, so we're just going to go ahead and do number 2 now. This is vector, guys. Vectors. Okay, just zoomed in a bit there. Okay, so we have with respect to fixed origin O, the point A has a position vector, blah blah. Okay, given that AB is stat, find the coordinate of point B. Alright, so there's a couple of ways you can approach to solve this problem. You can say that, well, AB is basically OA plus AB, right? Or you can use something like, well, because to find the relative vector AB, we can do OB minus OA. I mean, it's just playing around with the algebra of the vector equation there, right? I mean, either one seems fine. But because we need a vector B in this case, yeah, coordinates of vector B, so we need to find the position vector OB. So OB, we make OB the subject, maybe from this guy. So it's going to be OA plus AB. Right? And that makes sense if you think about the order of the letters in the equation. O to A, and then repeating A, and then to B. Just see the pattern there, right? Okay? So that means we need to add 7 to minus 5 with AB minus 2, 4, 3. And that would give me, I'm just going to write here, maybe save more space. Okay. I think I'm going to need to keep this around. Yeah. Alright. Hang on. That's fine. So when we add them up, we get 5, 6, and minus 2. Yeah? Now because it asks for coordinates of B. So coordinates of B, we write B, and then it would be 5, 6, and minus 2 like this. So that's the way you write coordinates in math, right? Just is the coordinates x, y, z of a point. Yeah, I'm just checking the math there. I think I'm happy with that. So that is A, very easy. Now we do B. Just keep going down there. The point C has position vector OC, where A is a constant. Given that OC is perpendicular to BC, okay? So OC perpendicular to BC, find a possible value of A. Okay, when there are two vectors perpendicular to each other, that means if you do a dot product, it will give you a 0, right? Yeah, so if U perpendicular to V, that means U dot V should be equal to 0. Because if you think about the dot product formula, there is a cos theta. So u dot v is equals to absolute or modulus u modulus v cos theta. Now, when there are two vectors perpendicular, the theta is 90 degrees. And when you have cos 90 degrees, that is 0. Well, that would make the u dot v become 0 then, right? So we can say here, because we are given that OC dot BC is 0, and OC is A 5 minus 1 as given there from the question, right? And then BC, what is BC? Okay, do we know BC yet? We know the point B already, but we don't know point C. Well, we are given OC, so that is the coordinates of point C. So because BC, again, I'm just going to do OC minus OB, right? Quickly, just to get the vector of BC there. So OC is just A, so I'm going to do inside the same column here. So BC is C minus B, so for X is A minus OB. We already got B from previous, so that's this vector right here, guys. And then the Y component is 5 minus 6. And then the J component, sorry, the Z component or the J component, the K component is going to be minus 1 minus minus 2. Yeah? Equals 0. So if I sort of do all the multiplying in there, I get A minus 5 for the first component. So when you do dot product, X components multiply X component, Y component, Y component, and Z component, Z component, and equate them, add them up, equate them to 0. Right? So this is 5 for the second one, 5 multiplying minus 1, I get minus 5. And then minus 1 multiplying, minus 1 minus minus 2 is 1 there. 1 multiplying minus 1, I get minus 1. So that should put to 0 there. Alright? So that is quite simple to solve because you just solve it. Right? So here is, well, we can do a squared minus 5a minus 6 equals 0 here. Right? I should write a bit bigger, right? And, well, yeah, I think, is it possible? Yeah, I think we can factorize that. So I'm going to do a minus 6 and a plus 1 equals 0. How about that? Right? That works, yeah? So do we have any limitation of a? Well, it says possible values. So we can have two values. So a is minus 1 and 6. And that would be the answer, right? Minus 1 or 6. Yeah? That vector question is easy. All right. Let's jump to the third question already then. The curve C is defined by the equation, blah, blah, blah. All right, so I need to zoom out a bit. There we go. Okay, just so that you can see as well. Yeah, we have this curve equation. Find an equation of normal to C at 0.25, giving your answer in the form of that. Right, so we need to find the equation of normal. That means we need to know the gradient of the normal. But usually the gradient of the normal can be found by knowing the gradient of a tangent to the same point first. And the gradient of the tangent to a point in a curve, we do differentiation to obtain the derivative of the function to find the gradient. And in this case, it seems like we need to do implicitly because the function is not in a very organized manner to differentiate dy by dx directly. So we do implicit differentiation, guys. And it's like I'm just going to apply d by dx operator to the whole equation. So let me write that. So I'm just going to d by dx, all of that, with d by dx on the other side too, right? So that is how we provide the working for implicit differentiation. So this is just basically differentiating each term sort of respect to its own variable, but if the variable isn't x, then we're going to have to do a chain rule. Let me show you. Well, but the right hand side is pretty easy. It's just 0, right? But the left, let me just put that to the right a bit because I think I need more space on the left, right? Okay, so let me move that up a bit. Like if you sort of like distribute the differential operator into the brackets on the left hand side, it's like differentiating the first term. So differentiating 8x cubed, you bring 3 down, so that's 24. And then x cubed would become x squared. That's it for the first term. Just as you would differentiate normally in P1 and P2 and P3. But now for the y, the second term, so minus, the second term is differentiating 3y squared, so bring 2 down, you get 6y. So that is as if you looked at y as an x, but because y is not what we differentiate respect to, we are differentiating with respect to dx, right? So because y is not x, we're gonna have to just add another dy by dx there. That is called chain rule again, right? Now what about 2xy? Well, for the 2xy here, we can look at 2x and y as separate functions because x and y are both variables. So we cannot treat either of them as a constant, okay? So let's do a product rule here because we have two functions multiplied together, right? Okay, so I'm gonna do u dv plus v du. So this is plus and in brackets maybe. U is, let's say u is our 2x and v is the y. So u dv, now you are differentiating y with respect to x. And because y there is already minimal, and by minimal I mean you can't, so if you're differentiating y, you're just going to get 1, right? Just like differentiating a single x. But because y is a different variable, so we're going to get 1 times dy by dx. So that is just dy by dx basically. And let me just delete this a bit. Let me put 0 later, yeah? Okay, now differentiating u dv and now v du, so we write v and du. Differentiating 2x, we just get 2. So 2 multiplied y, I get 2y there, equals 0. Because differentiating 9, we get 0. Now, in order to get the dy by dx, maybe we can isolate dy by dx first, okay? So let's put dy by dx equal, right? So I'm gonna maybe simplify them on the same side here. So if we look at just the dy by dx terms, we get 2x minus 6y here on the left. All right, and then we move minus 2y to the right, minus 24x to the right as well. So dy by dx as a subject is going to be equal to, well, 2y. I can maybe bring the minus out, so I get 2y plus 24x squared. But then this minus sign that I pulled out will be sort of like multiplied into the 2x minus 6y, so I get 6y minus 2x instead. And if you want to further simplify that, we can divide everything by 2, so we get y plus 12x squared divided by 3y minus x, yeah? No, that's not the answer yet. So m of tangent, yeah, would be equal to, we're substituting x and y into our dy by dx to get the gradient, right? So 5 in the y and 2 in the x. Again, 5 in the y and 2 in the x, right? Okay, because the point is 2, 5. I'm just checking. Just being careful here. All right. So let's do the math there. Okay, on top we have 5 plus 2 to the 2 is 4. 4 times 12 is 48. 48 plus 5 is 53. Divided by, what is that on the bottom? We have 15 minus 2. We have 13. And that doesn't seem to be divisible, is it? No, I don't think so. Let me check a bit. Yeah, the number is intriguing, but we should check this later, right? Let me check from the beginning. That's what I think I should do. So if I differentiate, yeah, I think I'm happy with that. Factorizing dy by dx out. Moving that to the other side. Swapping the term there. Taking the minus sign out. Substituting y as 5. Oh no, I see my mistake. Oh no, that's right. It's not a mistake. 48 plus 5 is 53. 15 minus 2 is 13. Yeah, okay, I'm happy with that. So that means the gradient of the normal would again be the flip and with the minus sign of that gradient of the tangent. There you go, just flip the fraction and put the minus sign, yeah? Now, so the equation of the line is y minus y1, y1 being 5, equals the gradient m times x minus x1 being 2, just using the same point really. And we can see that we should multiply 53 out across the entire equation. So that would be 53y minus 53 times 5 is 265, I think. Yeah. And that would cancel to, hang on. So that would cancel. And if I multiply minus 13 in, so I get minus 13x. Minus 13 into the minus 2, I get plus 26. Okay, so that would be 13x plus 53y. And what is that? Let me just help myself with the calculator here. So minus 265. What was that again? Plus 26. That is minus 239. Yeah. So that would be the equation, guys. Looks like the numbers are quite big, but anyway, we'll take it because I've checked once. So yeah, not gonna spend more time checking it again. Then move on to number 4. Let's check. Okay, yeah, all are integers, yeah. Number 4. Figure 1 shows a sketch of a segment PQRP, yeah, okay, PQRP, with a center O radius 5. Given that angle POR is theta radians, theta is increasing. Okay, so this is about rates of change because theta is increasing from 0 to pi. Okay, at a constant rate of 0.1 radians per second. So that is giving us d theta by dt. All right, the area of the segment is PQRP is A. All right, so that dA by d theta is that. Okay, so the general technique for this rates of change topic is, again, you think about all the involved variables. This is area, theta, and time. Area, theta, and time. Only these 5, right? Only these 5. So that means when you want to find something in particular, in this case, we want to prove for dA by d theta. So you write here dA by d theta. Construct the chain rule equation, linking all the variables together. The easiest way is to just dA by the other parameter, which is time, times dt by d theta. That is the easiest way to come up with a chain rule equation. Now, your job is just have to find dA by d theta. What would be the rate of area increase here? And dt by d theta. Is it given, right? So, in this case, right, we should construct, yeah, we are given that d theta by dt is equal to what? 0.1, right? Per second. Yeah, radian per second. Let me write that. Okay. And so if we do dt by d theta then, because we need to put that in our chain rule equation, so that would be 1 over 0.1, that is 10, simply. So 10 is waiting there. And now dA by d theta is dA by dt times 10. But I think, okay guys, I think I was a bit wrong here. I think this one is for B, right? This whole thing is for B. I think the first one is just, you know, we just differentiate the expression of area with respect to the angle. So the first one is just if we can find the area in terms of the angle, right? So yeah, if you want to find the area of the sector, yeah, this is area of the segment P, Q, R, P. That little segment there, just to make sure that we are not missing anything. So this is the segment we want, right? P, Q, R, P. It's not the sector, sorry, it's just the little segment there. So that can be found by finding the sector. So it's the sector here, minus the area of the triangle. Right? I'm just drawing out so that you can understand as well. So this A, which is the area we want, is the area of the whole sector, which is 1/2 theta r squared. If theta is in radian, that would be the formula. Okay? Minus, so because the radius is 5 and 5 on the sides of OR and RP and OP there, so we can use a sine. So that's half AB sine theta. So half times 5 squared times sine theta, right? So that would be the area. Okay, it seems like we can differentiate that respect to theta, right? So that would be kept later for B, right guys? Okay. So dA by d theta will just be found by differentiating that expression directly. Now, but be careful, right? Oh, r is a constant. R is 5. I forgot to just put this as 5. I thought r varies. So this is 5 squared as well, right? R squared. So it seems like we can, yeah. So if we differentiating the first term, we get 25/2. The theta just goes away, yeah. And yeah, I think that's fine. So the second term, differentiating sign, we get a cos, so that would just be 25/2 cos theta. And that seems to be it, right? Yeah, so if we sort of factorize 25/2 out, where k is a constant to be found, yeah, we get 1 minus cos theta there. So that is all fine, yeah, I think for that. This is as required. And that would be for B, right? Jump to that. Now, where were we for B, right? So we want to find in centimeters squared per second the rate of increase of the area. So we want dA by dt instead. Okay, so let me just delete everything out again because we want dA by dt. Let me write a better chain rule equation. So dA by dt again would be dA by d theta times d theta by dt. And d theta is already given to be, again, 0.1, right? So we can use that value. And dA by d theta seems to be already derived up there, right? And when theta equals pi/3, so we're just going to plug in everything, right? So this is 1 minus cos of pi/3, right? Times d theta by dt, which is 0.1. So if we do that math, we're going to get the rate of increase of the area. Okay, so pi cos pi/3 is cos 60. Cos 60 is 1/2. 1 minus 1/2 is 1/2. Yeah. So that would be 25/4 times 1/10. 5 cancel that is 2. 5 cancel that is 5. So this is 5/8 cm cubed per second. Cm squared per second. Just gotta write the unit down just in case. So that would be the answer. Okay, so that's done, guys, I think. All right. Yeah, I think that's all fine. So number 5 now. Ooh, what do we have? This is a long question. Okay, number 5. Figure 2 shows a sketch of a curve defined by the parametric equation that, okay, seems to have like a cutout on top here, where a and b are constants. Okay. Right. the ends of the curve lie on the line with equation y equals 1. Okay. Find the value of a and b. So look guys, I noticed that on this spot, on these 2 points, they give you t equals a and t equals b. And that is where y equals 1. So if we bring the equation of y equals 2 over t3 minus t there, and if we put this to 1 and solve for t, then they should be the answer to a and b, right? So we're going to put that to 1 according to that top line there. Yeah? And yeah, so let's solve that. So if I move the whole denominator, t times 3 minus t there, to the other side, I get that. And maybe multiplying them out, I get minus t squared plus 3t here. Bring them to the same side. I get this, right? So see if I can factorize. Yes, I think I can. So t minus 1 and t minus 2, right? So t is equal to 1 or 2. That means we need to state the value of a and b. If you only leave it like this, if you only leave it at this, you're probably not going to get marks. So you need to say, therefore, a equals 1 because it's to the left of b, smaller than b, and b equals 2. That would be the answer. All right? To part A. And then part B. The region R shown shaded in figure 2, yeah, is bounded by the curve and line with equation y equals 1, of course. Show that the area of region R is given by that. Okay, so we're going to do integration to find that area. Now, yeah, okay, so it's like we have the line y equals 1 with the curve here, and then we're going to integrate that, right? So, yeah, I think we can do this, right? So if we integrate, I mean, I'm just going to draw this for you. Okay, a little graph, and this is the line y equals 1 right here. And that's the curve there, okay? All right, so we want the area in the R, but if you think about it, I mean, if you try integrate the curve from whatever this x value and the other one are, so let's say that is x1 and x2 to be found, because we can find that by just putting, yeah, actually, you know what, let's find that first. So we want to find the x value at that point first, at those 2 points. So that means we put t as being 1 and 2 in the x to get the points. So x1 might be put t as 1, so we get 1 plus 2 times 1, that is 3, and x2 would be put in as t is 2, t is 2 is 4 here, plus 2 times 2 is 4, so the other one is 8. Yeah, so that is just 3 and 8 there, all right? Okay, now look, if you integrate the curve, whatever the equation is, we don't know yet, we're going to find it soon, somehow, you're going to get the area underneath this, and not the area R, right? So that means if we want to find that region R's area, we need to do maybe subtraction method. So we do the big rectangle subtracted by this cutout, like the area underneath the curve, to get that area R, right? So just visualize that, just to make sure you know what you're doing, guys. Or at least I know what I'm doing, all right? Okay, but how do you find the area of the rectangle? Well, that's quite easy. I mean, a grade 5 student can find that, right? Because if you know the base, if you know the height, then you can find the area. So this one is basically just 8 minus 3, the base, times the height. Why do I write that? The height is just 1, right? So that is it. That is just the area of the rectangle. Minus, now we need to do some integral here. Now, but this is parametric, right? The way you do integration is by parametric. So that is going to be, because normally we do y dx, So if you put y dx by dt, that is also possible. Because look, algebraically speaking, dt will cancel. But we're not going to cancel them because we're going to put y as a function of t, dx by dt as a function of t, and dt, because we're integrating to t with respect to t now. So there you go. Y as a function of t is 2 over t times 3 minus t. Dx by dt, well, if you differentiate dx by dt, yeah, I can write this first. Just quickly there, so you get 2t plus 2, right? So integrating to t to the 2, you get 2t, differentiating t to the 2, you get 2t, differentiating to t, you get 2. So I'm going to put 2t plus 2 here in brackets. And then that is all that is, so and dt here. So we're going to get region R here, area of region R is just that. Let me just put this aside because I don't want my marker, which is me, I mean the person who marks the paper later on, to be confused. All right. Okay. So this is just 5 then, minus. We're going to put the right bounds to this as well. And that seems to be just t from A to B, basically. Right? Just from A to B. All right. Yeah. So the bounds will also be, we got A to B from, yeah, so that's 1 to 2, right? There you go. From the right bounds. Okay, so how can we integrate that? Well, it seems like we need to do a partial fraction, right, guys? Because why? Well, I can show you. So 1 to 2 there. If we extract 2 out from that brackets, we get t plus 1 in brackets. But then 2 that comes out will multiply with another 2. So I get 4 out here. I would like to bring constant out of the integral first, because sometimes you get large numbers in the integration and you can get confused. So here would be t plus 1 or divided by t. Now here I can change to t minus 3 too. Yeah, just by multiplying by minus 1, but then when I do that, this will become a plus. Just to simplify so that it looks simpler to me, because I like things that way. Yeah. Okay. Now let's do partial fraction, right? So partial fraction here, in order to integrate that term more easily, partial fraction of that, right? So basically we do t plus 1 over t times t minus 3 would be equal to some constant over t plus some other constant over t minus 3, right? So we're going to get the partial fraction of this. Why? Because then separately each term will be integrated to become a ln, right? Okay, so the way I would do partial fractions is to just multiply out by this guy on the left side. So you would cancel everything, and this term will cancel 1t, so you only have t minus 3 there. The other term will cancel the other term. I hope that makes sense. And now quickly then, I'll let t be 3. Yeah. So you found the critical value. This is 3 and this is 0. The critical values would be the one that when you substitute in each bracket, it will make that bracket go away entirely. So this one is 3 and 0. Okay, now when you sub t as 3, you get 4 on the left. The a term goes away. Then you have 3b on the right. So that means b equals 4 over 3, just to solve that. And the other one is t being 0. So the left side, t being 0, would be 1. All right. And then the b term goes away. T subs as 0, we get minus 3a. So that means a is minus 1 over 3, right? Okay. So minus 1 over 3 and 4 over 3 would be the constant. That means we can now proceed with our integration. So r would be equal to 5 minus, sorry, it's a plus now because we changed we simplified to that. Integrate from 1 to 2. t plus 1, and the whole thing would become a being minus 1 over 3 of of what? Of t, just one t. And then b would be plus 4 over 3, right? Of t minus 3 dt. So basically we are integrating whole thing using partial fractions, all right? Okay. So here we go, we have 5. Okay. So just going to integrate that first. So that would be a minus 1 over 3 ln t. Now we don't need to put the modulus there because we already know that the two bounds are positive. Okay, this is a plus. Integrating that, we get 4 over 3 ln, well, for this we do, right, t minus 3. We do need to put the bounds in. Yeah, that's okay, yeah? But before we do that, okay, the bounds are 1 to 2. Let's simplify the ln terms, okay? So we can do that by, if you consider you can sort of like bring 1 over 3 out, and inside you would have 4 ln t minus, hang on, t minus 3 minus ln t, right? So I haven't done anything with the bounds yet, just keeping it. And again, keep writing. So inside here you can put 4 to the power for the ln. That's just one of the log properties, yeah? Yeah, and then I would bring 1/3 out there. So inside here, if you do ln t minus 3 to the 4, yeah, so that would be ln t minus 3 to the 4. You can cancel out the modulus because anything to the power of 4 would be a positive number. But because you minus ln t, so using another log property, you can do that. Just merge them, merge the ln. So basically log a minus log b, you get log a over b. And then we sub the bounds later here. Okay, so let's see how far we have gotten here. Oh, I think I've gone too far, right? I think I've probably done almost the whole thing there. I haven't checked the question at all. Okay, hang on. So I think question B we can answer as okay, that's the partial fraction. So I actually need to change. Yeah, okay. So look, guys, I think I'm gonna need to just arrange this to what they want. Just shrink down that first. Okay, and I'm just gonna put answer B here as, okay, so they don't, yeah, they don't simplify it like I do. Okay, so yeah, wait, hang on. Oh, I think B is already here, right? Okay, B, my answer to B is here. Yeah, they didn't put a minus. Okay, I'm gonna just bring back the minus sign. So by that I mean I can change this back to 3 minus t, right? Because that's where I got it from, and that is it. Yeah, that is it. Okay, so that is my answer to B. And then for C, partial fraction. C, this is C, partial fraction. Okay, write that in partial fraction. So I already have it here. So let me just tidy up a little bit. So I'm just gonna move that down so that I can write the answer to CI. Yeah. So I here, t plus 1 over t3 minus t would be equal to, well, hang on there. So I'm gonna have to do a minus there because I did t plus 1 over t times t minus 3. Okay, so I have to put 1 minus there. And then I can write minus the whole thing that I put, right? So it would be a, which is minus 1/3 over t. plus b is 4/3 over t minus 3. So that would be 1/3 over t minus 4/3 over t minus 3. Yeah, so that is the answer. Here we go. And then use algebraic integration to find the exact area. Okay, yeah, that's it. So bring us back to where we were now. CII. Okay, here we go. All right, so we're just gonna keep integrating that. Okay, so we were up to this point, right, where we try to put the bounds in. Okay, so 5 plus, yeah, so if we put 2 in the t, we get a -1. -1 to the 4 is 1. 1 over 2, so that is ln 1 over 2 when you sub 2 in there. B is 2, yeah, I think. Yeah. And then sub 1, if you sub 1 in, you get a ln, what is that? It's 2 to the 4 is 16. 16 over 1 is ln 16. Wow, okay. I get a minus sign here somehow. Right, so let's see. Yeah, let's actually calculate that, but this is the exact area in simplest form. Okay, let's do ln half. What is ln half? Minus ln 16. That is a minus. It's a negative value. It means I'm in trouble. I should get a positive value. Okay, let's have a look at all the things again. See if I made any sign error there. Okay, so because I'm taking the minus sign out. Okay. Well, actually, let me do the entire thing again, right? So maybe I shouldn't do it my way. Let's just delete everything and put this into the right expression as shown earlier. Yeah, maybe that's gonna do better. So we're gonna have a minus here instead. Okay, so we have a minus here, and then the partial fractions would be, yeah, so 1 over 3 over t minus 4 over 3 over t minus 3. Yeah, just like that. Yeah, I think that's fine. Or should I not change that actually? Let's do plus and swap the sign. All right, I just feel like sometimes it's tricky with the ln after you integrate, so that's gonna be changed to that, and maybe I'm gonna do that instead, just to, yeah, okay, like that. Keep them all positive. And yeah, let's do the integration again. It's fine. So that would be 1/3 ln t plus 4/3 ln, yeah, this time it might make sense. That's why they put 3 in front of t, because 1 and 2 is smaller than 3. Okay, so I'm just gonna follow them then. Okay, so yeah, now let's do it like this: 1/3 ln 2 minus ln 1. So basically I'm substituting 2 and 1 for each term. So I'm substituting 2 bounds for each term already. And then plus 4 over 3. And then what do we have here? So if sub 2 in, we get ln 1. Sub 1 in, we get ln 2. Yeah, just like that. All right, and we simplify the whole thing. That should work now. So ln 2 minus, so ln 1 goes away because it's 0 basically. So here we have 5 minus 4 multiplying in, we get 4 over 3 ln 2 for the first brackets. And minus 4 multiplying into the other side, we get a plus 16 over 3 ln 2. So there's a minus term in front of ln 2 as well. That's why we get plus there. Yeah, I'm happy with that. So we can merge the ln 2 there. We get, so if we do the math there, is 16 minus 4, we get 12. 12 over 4, 12 over 3 is 4. So that's plus 4 ln 2. So that is simplified to me. Yeah, so that would be my answer. So the learning here is to follow their suggestion in terms of the expression they want us to prove. Okay, so that's it. Question 6. I think we are okay with the time, hopefully. With respect to fixed origin, another vector equation. Okay. A show that at A, the parameter lambda satisfies that equation. Okay, so lambda is just a constant there, scalar parameter. Point A lies on L1. Okay, so if point A lies on L1, that means OA here, which is the, they give us the distance of OA to be 5 root 10. Okay, so we can write vector R as a column manner here. So it's 1 plus 8 lambda. Yeah, just merge the I components. The J component 2 minus lambda. And then 5, the K component, plus 4 lambda as a column vector like this, right? And then we want to find the, so the, if because A is on this line, that means if we equate this to vector A, and then find the modulus or the length of this vector, we should get 5 root 10. So that means the modulus here would be put to OA, which is the length of vector OA. And that would be doing the Pythagoras, guys. Yeah. So it's basically just that squared, and that squared all together. And that is to be put equal to 5 root 10, right? And if we sort of like square the two sides, yeah, square the two sides, we get 25 times 10 on this side, so that's 250. Because that means we can cancel the square root on both sides, yeah? So on the right side I have everything the same thing, but now no square root. And if I expand all that, I can solve for lambda. Can you see that? Because we're going to have to aim to get a quadratic expression there in terms of lambda, right? So you see that if we expand, we should get that. So I'm expanding this using a squared plus 2ab plus b squared. So a squared plus 2ab, which is 16, plus b squared, which is 64 lambda squared. Again, 4 minus 4 lambda plus lambda squared for the second one. And for the third one, I'm running out of space there, so I'm going to do here 25 plus 2 times 5 times 4, that is 40 lambda, plus 16 lambda. Okay, simplifying all these, hopefully we can get what they want. So if we do the lambda first, I'm switching to the right side. Lambda squared, I mean, so 64 plus 16, we get 80. 80 plus another one, we get 81. Yeah, so there seems to be 81 there. And then the lambda term, so we have minus 4 plus 40. And then plus another, oh, God, I forgot this lambda here. That's why. Okay, so there's another lambda here. So 16 minus 4 is 12. 12 plus that is 452 lambda, right? Got to be careful with the writing here because sometimes the lines can, oh, there you go, crash. Sorry about that. Oh no, sorry. That's embarrassing. Okay, here we go. Do not crash again, okay? Oh no. Oh, that's not good. everything just disappeared, right? Okay, so I'm gonna have to maybe go back, check my video, check the recording, and take a screenshot to this, right? I'm not gonna write everything again. Yeah, guys, that would be unfair. So I'm just gonna have to leave it at that. And then where was my question 6? So I think, yeah, I can maybe try do question 6 again. Okay, but quickly, guys. I think you can excuse me on that. So that for R. So I have that squared plus 2 minus lambda squared plus 5 plus 4 lambda squared equals 5 root 10. Square both sides and simplifying them. 1 plus 16 lambda plus 64 lambda squared plus 4 minus 4 lambda plus lambda squared plus 25 plus 40 lambda plus lambda squared equals 250. Okay. And then adding up the lambda squared, we get 81 indeed. What's that? Oh, hang on. I swear I wrote that. This is, yeah. Okay, so this is 16 lambda squared, or maybe I didn't. So I get 81 lambda squared here. And then do I get 52? So 16 plus minus 4 is 12. 12 plus 40 is 52 lambda. And then the constant term 1 plus 4 is 5. 5 plus 25 is 30. And then 30 subtracted by 250. Yeah, we do get that as required. So this is A, right? Question 5, I'll just take screenshot from what I wrote earlier from the recording. So I hope you guys don't mind. Okay. BI. Show that one possible position vector for A is that. Right. So basically we're going to solve that, right? Solve the quadratic. Now, okay. Because my calculator can't solve quadratic directly, I'm just going to have to maybe make do of what I know here. Okay. We show that one of them. So look, if I do it a bit tactically here, because we already know that OA is, hang on, we already know that the position vector is, so we can use this. Because they say that the I component is minus 15. So if we equate this to minus, 15, we don't get lambda equals minus 2. But we don't write this as the working, right? This is working backwards. So we know that lambda equals 2. That means one of the answers should be, right, 2 plus 2. Yeah? Okay. And if we do, what do we do? If we do long division maybe? Or I can do short division. I prefer short division maybe. There's something called short division. I can show you quickly. So we take the critical value minus 2 instead of plus 2. And we do this. So we do 81, 52, minus 2, 20. And then we bring this down, 81. Minus 2, we multiply 81, we get minus 162. But we add instead of subtract. So this is against, this is the opposite to long division. So we add these, we get 90, right? No, we don't. What do we get? We get minus 110. Yeah? And then we multiply minus 2 to minus 110, we get plus 220. And when we add them, we get 0. That confirms that it is a factor. It's like, it's divisible. There is no remainder. But the result here means that we have to put 81. So this is basically 81 lambda squared. That means the number here will be belonging to the term lambda. So that's 81 lambda minus 110. So that's it. So this is lambda plus 2 and 81 lambda minus 110. So if you check multiplying back in, you should get the number you want, right? Hopefully. Hang on, let's check. Yeah, I do get that. Equals 0. That means lambda equals minus 2 and 110 over 81. Yeah, that's how to work backwards. So you check what you got first and then Yeah, there we go. We're gonna delete this because the marker wouldn't care about this anyway. So that would be how I would do it without a calculator if the numbers are too big to factorize quadratically. Okay, so yeah, we showed that one possible and another one. So if I sub -2 in there, I get r equals, yeah, just sub 1, sorry, -2 in there. 1 plus -2 times 8, 2 minus -2, 5 plus 4 times -2, and that would be, yeah, -15 as expected, plus 4 as expected, -3 as expected. All right, so OA there would be equal to, of course, writing as required there, don't forget. And then the other one is just subbing r equals the whole thing again, but now putting 110 over 81 in instead. Yeah, 2, what is that? 2 minus lambda, so 2 minus 1, 110 over 81. And then the other one is 5 plus 4 lambda, 5 plus 4 times that. I'm gonna need a calculator for this. Okay, so this is another one is OA being, okay, calculator, come on. So 1 plus 880 over, hang on, that's not over 81. And then I can change to a fraction. So that is 961 over 81. Okay, let me just expand that a little bit. Hang on. Okay. And then what do I have here? 2 minus 110 over 81. Wait, hang on. Over 81. And then changing that to fraction, we get that. And then lastly, 5 plus 440 over 8. That is just 60. So our OA would be, let's move that down a bit. So 961 over 81i plus 52 over 81j plus 60k. Yeah, that's another answer for R or OA. Now the last part here, the line L2 is parallel to L1 and pass through O. Okay, pass through O as well. Line L2. Gotta be careful this time. I made a silly mistake last paper about vectors, because I didn't read the question carefully. Given that OA is that, so we are taking as lambda being -2 here for OA. Point B lies on L2, where OB is, you know what guys, I think I need a toilet for 1 minute. I'll be back. All right, sorry. Okay. Point B lies on L2 where OB is 4 root 10. Okay, so point B lies on L2 where OB is 4 root 10. Find the area of triangle OAB. Okay. So let's draw some lines, yeah? L2 parallel to L1 first, so that's L1, that's L2. And then L2 passes origin, so let's say that's origin. And L1 here has point A, so let's say A is there. Okay, that's A is on L1 and point B lies on L2, right? So let's say point B is there, maybe. Okay, So OA here is where lambda is equal to -2. All right. OB is 4√10. Okay. They're parallel. Okay. Find the area of triangle OAB. All right. So we know OB here, 4√10. Yeah, okay. So this is 4√10. Interesting. We can also find OA, the length, I mean. But if we want to find the area, we can use like we can find the angle between these two vectors and do the 1/2 AB sine theta. But we don't quite know OB yet. I mean vector OB. Wait. Oh, no, sorry. It's the L2 that passes the origin. Okay. That's why it was a bit tricky. All right, so it is this. So it's like this instead. So OA here we already know, lambda being -2 on the vector equation L1, and OB is 4√10. Yeah. Okay. So yeah, because we know that, okay, we can write the vector OB here because we know that OB must be parallel to the direction of line L1. And line L1 has what I call a directional vector if you take just the part after lambda there, yeah? So if you take just the part after lambda, the directional vector here is 8, -1, 4 as a vector. So it's like the line is pointing that way, along that way. We can assume that OB is parallel to that vector, so I'm just going to write 8 -1, 4 like this, multiplying by some multiple k. That is vector OB. But we know that vector OB has that length, right? We can just take the vector there already. Now we're going to find the angle between the vectors and find the area, right? So yeah, just to find the angle here, we will find this angle later. But modulus OB would have to be 8k cubed plus squared plus 4k squared. I multiply them out and just do the Pythagoras here. That would have to be put as 4√10. So square both sides, and simplifying the square root there, I get 64k squared plus k squared plus 16k squared equals 4√10. Oh no, I gotta square this as well. So 16 times 10 is 160. Okay, so adding up the left hand side, I get 81k squared equals that, right? And k squared is equal to 160 divided by 81, so k is, so yeah, we probably have to take it as a positive sign, right? So I'm just going to take, okay, let's do plus minus here first. Square root of that, we get 4/9√10. Yeah, we're just going to take that. So k is 4/9√10. That's fine. Okay, so we're going to find the angle, the acute angle between OB and OA, right? So we do OA dot OB. So to find the angle between two vectors, we do a scalar product. ab OA times ab it's absolute, cos theta. Okay, so what is OA? OA is already found, right? OA is, yeah, it's given to be minus 15, 4 minus 3 there, dot. For OB here, I'm going to take it as K being positive. So let's do a, okay, let me just delete this because I'm going to do, yeah, you know, it's just, yeah, okay. So 4 root 9 times 8 is 32 over 9 root 10 for the x component. 4 over root 9, that is going to give minus 4 over root 9 square root 10. Okay, move up a bit. And 4 over 9 root 10 times 4, I get 16 over 9 root 10. Yep. So that is the OB. And then that would have to be put equal to modulus OA is already given to be 5 root 10. Modulus OB is 4 root 10 cos theta. So we're going to solve theta doing everything that. Okay, so we have the dot product on top. Yeah, I mean, if we get an obtuse angle, we're going to change it to an acute angle. But when you do sine theta, that is not going to matter, right? You will know what I mean. So this is minus 15 times 32 over 9 root 10 doing the dot product there. And that is also another minus. And also another minus. So this seems to be an obtuse angle, guys. Right? Okay. Or divided by, so that is 20 times 10 is 200. That's cos theta. So theta is just arc cos the whole thing. If we do arc cos of that, we get an obtuse angle. So I'm just going to make it positive then. Okay, if you don't mind. Bring that. So big fraction there. So what is the first one? Minus, hang on. Okay, that's fine, I guess. So 15 times 32 over 9. Root 10 up there. And then a plus. I'm just going to help myself as well here. 16 root 10 here over 9. And then another plus after all that. It's a bit tricky here, this calculator. Because I want... Okay. Yeah, all right. Plus 16 over 9. Hang on. Over 9. Times 3 root 10. And all divided by 200. Okay, I'm going to put that answer first. And then arc cos, do we want radian? No, it's fine. Yeah, we can do radian, or we can do degrees. Let's do degrees here, change to degrees. Arc cos answer. So arc cos answer, we get this to be 17.116. Yeah. And then if we do area, right? Area equals 1 over 2 AB sine theta, right? So that would be, let me just, yeah, do that. Make that go away first. So 1 over 2. Again, if you look at the triangle here, we are finding this triangle, OAB. Right? So that's just 1 over 2 OA times OB sine theta. Yeah? And OA is 5 root 10 again. OB is 4 root 10. And sine of that theta there. Okay, so where's my calculator? We're going to keep this angle. And then 0.5 times. So that becomes 200 again, right, guys? Times, what was it, sine theta. So that is 29.4 to 2 decimal, to 1 decimal. Did I say 29.4? Hang on. Yeah. Yeah, so that's it, the answer. Okay, I need to hurry up now. Let's see, how many questions do we have? 7 and 8. And 9, I'm in trouble now. Okay, number 7, I need to hurry up. The current X ampere amps time t seconds after the switch is closed. A particular electric circuit is modeled by that equation. Okay, so this is differential equation to find the equation in terms of K for the current given. Okay, so in integrating by separation of variable, we need to do that first. So I rearrange, bring X to the dx side, and this side would be nothing, just 1 dt. Integrating both sides, putting a 1 there just to make sure we don't forget. So this is integrating in respect to respect to x. So that's going to give us a ln k minus 3x. But then we need to do another a reverse chain rule. So that's going to be minus 1 over 3 there on that side. And that's going to give us t plus an unknown constant c, right? Okay, so we don't care about the initial conditions yet. Oh, initially there is 0 current, sorry. So when t equals 0, the current, which is what? X equals 0. Okay, so we put into that expression k minus 0 equals 0 plus c. So c is equal to, what is that? Minus 1 over 3 ln k. Can we simplify that? Maybe we don't need to. So that means x as a function of t would be, hang on, not yet. So we put everything in first. So minus ln 1 over 3 k minus 3x equals t minus 1/3 ln k. Yeah. Right, so let's bring the ln together. So it would be 1 over 3 here, ln k minus 1 over 3 ln all of that equals t. We merge the ln using log property. So we have 1 over 3 and then ln doing the log property there. So it's k over k minus 3x, or absolute maybe. Okay, because yeah, the ln k is also with the absolute signs, the modulus signs. So this is equal to t. Okay, so yeah, we can move it to the other side, yeah, so let's just do this first. So I'm going to have a cube root of a positive value. Yeah, ln of that, because I put 1 over 3 to be the power of that, and then I'm going to do e to the t. So I move ln to the other side, I have e to the t on this side. And if I do power 3 on both sides, I get e to the 3t, and that can just be this. Right? Yeah. So not done yet, but almost there. K is a constant. We can't really do anything to that, right? Okay, I'm just gonna assume that we can sort of like cancel out the modulus sign here. So I'm gonna have k, and then if I multiply that to the other side, I have k minus 3x here. And then expand them, I get k e to the 3x e to the 3t minus 3x e to the 3t. And then if we isolate for the x, we're gonna have this. Yeah, moving k to the other side. And then yeah, so 3x, or if we want, we can do x already. X equals k e to the 3t minus 1, all divided by 3e to the 3t. So that would be my answer there, maybe. All right, B. Need to hurry up a bit. B, find, given that in the long term, the current approaches 7 amperes, find the value of K. Okay, so if T tends to infinity, that means T tends to be a very, very large number. Okay, so X will tends to, well, this will go very large and this will go very large. It means we can cancel the -1 there. That means they will also cancel, and K will tend to K over 3. So that means K over 3, we can put it equal to 7. So K is going to be 21. Just quickly there, guys. C, hence find the time in seconds it takes for the current to reach 5 amps. Giving your answers to two significant figures. So we put 5 equals, using our expression, knowing that K is 21. So 21 over 3, e to the 3t minus 1 divided by e to the 3t. All right. I hope my expression was right. This canceled to 7. And then if we do a cross multiply, do we need to do that? Yeah, let's do that. So doing a cross multiply, we have 5 e to the 3t equals 7 e to the 3t minus 7. Okay, so 7 equals moving 5 e to the 3t to the other side, we get this. So e to the 3t equals 7 over 2. All right. So that means t equals ln 7 over 2 divided by 3. We have to put two significant figures, so bring the calculator. So it's ln 3.5, yeah, divided by 3. So that is just 0.4175, blah, blah, blah. So the two significant figures, just 0.42 seconds. Okay. Just bring back the cap. Hang on. Okay. That's the answer there. Okay, next, number 8. I'm running out of time again. Okay, so show that binomial expression. Okay, so if we see this, we need to bring 8 out first. So 8, 1 minus 3 over 8x, and then all to the power of 4 over 3, right? So we're going to have to do 8 to the power of 4 over 3 here, and then in parentheses, the entire binomial expansion. So I'm going to use the formula, guys. I hope you know the formula. So it's 1 plus n, and then x, which is the second term, plus n times n minus 1, which is 1 over 3, times x squared, times the second term squared now, divided by 2 factorial. We just need up to the third power there. So another term, 4 over 3, 1 over 3, minus 2 over 3. Just minus another 1 there. And this will be to the power of 3 divided by 6 factorial. Okay, so that's the expansion. So I'm going to do the math here already. Hope you don't mind. So 8 to the power of 1/3 is 2. 2 to the 4 is 16. Yeah. So 16 here, bearing in mind. I'm just going to have to do that. So this first term will be 16 plus. Okay, so 4 cut 8, we get 2. 3 cut 3, so this will be a minus. So that's 1 over 2 there. 16 multiply in, we get minus 8x. Okay, so what about this? I need a calculator maybe, just to be safe. So the third term there would be 16 times 4 over 3 times 1 over 3 times 9 over 64, and then divide by 2 down there, so I do that. So that would be just 1 over 2. Okay, I already take into account the 16 outside, so that's 1 over 2 x squared. Now the third term is a bit more fun, 16 again, times 4 over 3, hang on, that's not, times 1 over 3 times, there's 4 minuses, so they cancel, 2 over 3 times, so that's 3 to the power of 3 over 8 to the power of 3, yeah, and then multiply at the bottom again by 6, which is 3 factorial. Changing that to a fraction, I get plus 1 over 24x cubed, and that is just probably as required because it is in that form. Okay, so B. 7 minutes. You use proof by contradiction to prove that the curve with equation that does not intersect the curve with equation that. So we need to assume, right, assumption that curve with equation y equal 8 plus 8x minus 15 over 2x squared has does intersect, it's just the opposite, with the curve with equation y equals a. Yeah, okay, we gotta do our equation here now. Okay, that's the assumption done. So we assume that they do intersect, so that means we can follow our assumption, make them equal, right? Like that. So if they have solution, they should have answers there. So I'm gonna move everything to the right part. So I'm gonna have 1 over 24 x cubed, moving 15 over 2 there, I get 8 x cubed, and then I have minus 16x here, and then I have plus 8 equals 0. That's a bit tricky. Okay, so I'm just gonna say that no solution because I know how it ends. Therefore, the two curves don't intersect. That means this contradicts the assumption. Therefore, the two curves don't intersect. Okay, that's just the way I would go about that. And the last question, number 9. We still have number 9 to go, and it's quite a lot. Okay, so volume of the solid. So okay, volume is pi integral y squared dx. Okay, so it's pi y squared there, so I get integral of x to the minus 1/2 on top there, over, if you square everything, you get 1 plus x down there, and that is just squared of the arc, tan root x, whatever that is, just writing it down first. We're gonna use tan u as square root x. So okay, so tan u equals square root x. That means arctan x, arctan square root x equals u, right? So that's the substitution. So we're gonna do here d tan u by the x. So differentiate tan u, we get 6 squared u, right? 6 squared u here, du by dx, and differentiating on the right side. So if you differentiate the left side, you get 6 squared u du by dx, a chain rule, and differentiating the right side, you get 1/2 x over minus 1/2 to the power of minus 1/2. So here, if we want dx as a subject, I would get dx equals 2 6 squared u times root x, and then du right here. Okay, that's a bit tricky. So that means volume would be now integrate 1 over root x here, 1 plus x. Arctan root x is u, so this is u squared, and then dx is 2 6 squared u root x du. right? So see if we can cancel anything. Okay, so I see because, wait, so from this, right? So we have 6 squared u is 1 plus x, yeah? Just using the identity there. So that's also 1 plus x, so that's going to cancel that. And root x cancel root x, so that's going to be pi integral of 2 over u squared du. So I'm just left with that. So integrating already, we get minus 2u to the minus 1. Putting in the bounds, a from b. Oh, we want to show, so hang on. X equals 1/3, u equals what? 1/3, 1/3. Okay, x equals 1/3. U would be pi over 6. Okay, and when x equals 3, u would be pi over 3. So I have pi over, hang on, pi over 6 here and pi over 3 here. There you go. Is that right? Yeah, it should be. And then we are gonna integrate that, see if I can in time. So pi is minus 2, 3 over pi, minus 2, 6 over pi. And then that would be 2 pi over 6 minus pi over 3. So that would be 2 pi cancel here. So that would be 6. Answer. Okay, so 6 is my answer here and time is just up. All right, guys. Okay, so this is the mark scheme for P4, May, June 2024. Let's see how many marks I got. Okay, I'm going to use a red pen here just to mark everything. Number 1, got it. That's fine. Yeah, I spent quite long at the very beginning, so I'm not sure if I got everything right there. So that is 5, 2 minus 2, 5, 6 minus 2 there. That's to answer here for that. Number 3. Yeah, this one I wasn't sure, but whoa, no, that wasn't right. It's 13x plus 53y minus 239. Yeah, I got right up to this. So that was a silly mistake. No, that's embarrassing. Oh yeah, this is a minus. Yeah, that's why I have a -1 here. Super silly, right? Yeah. That's not good. Okay, I can show that. Yeah, 5 over 8. Good. So for number 5, because there was a technical issue, like somehow the app just blipped out and everything crashed. So I just took these screenshots from the recording, and here I'm gonna mark it. So I hope that's fine by you guys. So part A is 1, B is 2, so that was fine. Part B, I could show that as required. And then this is supposed to be part C actually. I should have, yeah, this should be part C. And then that was 1 over 3t and 3 over 4, 3 minus t. Yeah, so that was fine. Although I don't write exactly as how they do. But that is a little different. I don't have exactly the same expression there. Yeah, something to do with the sign error, I guess. So, never mind. Number 6, now I have lost 2 marks so far. Number 6, I could prove that, so that's fine. And for B, ooh, this is going to be a long vector here. Okay, wait, for I, BI, yeah, I could prove that I have factorized, so I could, yeah, so this is what I did. I found lambdas to be -2 and 110 over 81, and I could prove that. And the other vector is just plugging in the other number. Ooh, but wait, why is that not 40? I got 60 for that. How come? Oh no, what have I done? This is 81. See how that was so silly? Okay. Bad. I forgot to write 1 there because it's 81. It wasn't 8. How did I? Yeah, okay. Look at that, right? Okay. So, yeah, so this is wrong. What is the A star mark there? Let's have a look. Yeah, I think I lost 1 mark there. I got the A star mark because I found 2 OAs. Yeah, so this is just -1 for that. Now 3 marks so far. And I got that fine, 29.4. So everything should be fine. I use that. And that is just the angle. Yeah, good. 3 marks so far. So number 7. So where's the x expression? So this is a, yeah, k with 3. Is that okay? Wait, so this is k with 3, and then that would be that would be gone to 1 minus e to the minus 3t, right? It's the same, right? So let's see if they allow any other equivalent form. Yeah, okay, great answer. Yeah, I got that. So I got the mark here. This is equivalent. So this expression is equivalent to the mark scheme, to the one here. So I got the mark there. And the final marks, 0.42 seconds. That's fine then. So far so good. Number 8, not done yet. Okay, yeah, this is binomial expansion. Yeah, I got that right. This was like the last 10 minutes. I was so in a hurry. And then, so we assume that they meet. Okay, and we do that, right? And then we put them to equal, right? Is that? I lost 3 marks here for the proof. That hurts. That hurts bad. Okay, that's fine. Okay, for this volume integration here, so for A, we have shown that it is, yeah, what did we need to show? Yeah, it's up to 2 pi, I think. Hang on, where's that? Yeah, I think it's this, yeah. I think I showed up to that. Yeah. Oh, but I already integrated. Let's have a look at B1 there, because I'm not sure about these marks. I think I got that mark, right? Because it's 2 pi 1 over u squared there. But then the B1 mark, let's see. Correct limits for the integral found allow where seen, even in part B, and even if not attached to the integral, must be in radians. Yeah, I think I got all of those right. Okay, and for B, yeah, 6. This is like last minute, real last minute, a single last minute actually. All right, so how many marks did I lose? Minus 3, minus 4, minus 5, minus 6, so 69 out of 75. And that is how well I did it, although I couldn't get 100% raw marks, but I still got 100% UMS, guys. Let's do the feedback and tips. For number 1, if you have done enough practice on integration, you will recognize quite quickly that by parts with u being x will finish this up very quick, right? So I think that was fine. So try do more practice on by parts, yeah? That would help you with identifying which function to be taken as u. So the other function is v, sorry, dv by dx. But you know, my general technique for by parts, I have heard that people remember Lyeth or something, which is the order you choose for the u. But I would say generally, u is taken as the function that when you differentiate it, it gets simplified, or it helps simplify the other part of the integrand. So that's how I go with the integration by parts. I never have to remember any order of choosing, but I just go with that. But sometimes when you do that and then the other function becomes dv by dx, if you can't really figure out which one should be u or v, then maybe try other methods like substitution. All right? So that first question was fine. The second one here is just about vectors. So you should know in general that a relative vector a to b can be found by just doing coordinates of b minus a, right? So that's not too bad. So if you have 2 perpendicular vectors and when they are dot product together, then you have 0, right? So that is very key there to that question. Now this one is implicit differentiation, right? So yeah, this is not too bad. I mean, it could have been worse. They could have put out more horrible functions like sine and ln and whatever. Yeah, I made a silly mistake here, guys. So I lost 1 mark here. Number 4, right? This is also fine. This is, yeah, I got everything fine. But this is about rates of change. I got confused at first, or maybe I got carried away too far before I read the question. So they asked for dA by d theta first. That has nothing to do with the chain rule equation yet, but I thought it would. But generally speaking, you would have to, if they want dA by d theta, basically you have to form an equation of area, in this case A, in terms of theta, because they want dA by d theta. So you form an equation of area in terms of theta first and differentiate respect to theta. Be careful when reading the question here, because you might think that they want some area if you're not careful. So PQRP is just that segment, right? Some people could read sector here, but it's segment. Segment and sector are different things in a circle. Gotta be careful there. So that was all fine. So number 5, right? This is parametric. And don't forget, parametric, you can do dy by dx. But in this question, they want you to integrate. So the integration form of parametric would be integral y dx by dt and dt, right? So that is generally the formula you use to integrate parametrically, right? And this is a mix with partial fractions. And yeah, so I lost 1 mark here. I couldn't, yeah, there was a sign error there. Didn't figure that out. The key to parametric equation is that you gotta be careful with the bounds, because you might be thinking, I'm integrating, I'm fine now, but maybe you would forget to change the bounds. You are changing from integrating y dx, so that y would be as a function of x. But when you change it to parametric form, which is a y in terms of t, that means the bounds should also change to the t values. And here you need to put the right t values in to get all the marks there. Very crucial here, right? Number 6, another vectors question. Took me a while to figure out, actually. But the first one, yeah, just prove that is quadratic. So that is just by doing the length of the vector there, okay, or the magnitude of the vector. And the second part here, we just solve for lambda, so that was all fine. And here I made a silly mistake. I forgot to write 1, so that was all wrong there. So the other vector, I didn't quite get it because that was wrong. Like I forgot to write a 1 there. That's why I somehow got it to be a nice number, so I didn't realize that that would be wrong. C here is to find the area of OAB. First, I didn't quite get the right orientation of the lines. I put O in L1, but actually O is in L2. O is on L2. And yeah, once you get the 2 lines and the angle between the 2 lines there, you can use 1/2 AB sine theta here, as I did. So that would be the area of the triangle there that you form. Yeah, but note that you might get an obtuse angle, which would have been fine because an obtuse angle, when you use it as a sine theta. Now, I think the key thing in this vector equation that might have made this question so hard is that OB is parallel to L1. I can put OB as a multiple of what I call a directional vector of line L1. The vector equation of the line L1 is this guy. Yeah, remember that this part here of the vector equation is somewhat the representation of the direction of the line. So that vector will point along this direction. It could be big or small, but it should point along the direction of the line, right? The other part here is just a given point on the line. So that doesn't matter as long as it's a point on the line, but this one is probably more important. That is why I put OB here as a k multiplied by that directional vector, right? Because it's given that OB is 4√10, so k can be solved. And when k is solved, we can use that to put in vector OB and find the angle. So that's what I did, right? So I found vector OB first and then find the angle between OA and OB and then solve other parts. So that was probably critical to solving this question properly, right? And then number 7 here, yeah, I think that was fine. This is about integration by separation of variables. So just move everything to the right places and integrate both sides. You probably have to be careful with the ln and the logs here, right, when you move things around. But yeah, I got the alternative form, which is also fine. So B is like, you need to figure out that given that in the long term, this phrase here, when you see long term, So it means t approaches infinity. You can try put t as a very large number and see what the function tends to, right? That also works. And then c, I just solve because they give you 5, so I just solved it. And t was 0.24, sorry, 0.42. Yeah, number 8, the first part was binomial expansion, so that was fine. Again, be careful in binomial when the first term is not 1. You need to do some factorizing. And don't forget to put the power into that factor you take out as well. That is usually forgotten from my experience. Okay? Yeah, this part I didn't quite get the marks here because, you know, I didn't prove anything that they want. So in this part here is quite important. So they try to factorize, yeah? After they have got, so if you put this one and this one equal, right? So from the binomial expansion, if you put this one equal to this one, and you want to prove that there are no solution, right? There's no answer to this equation because when you compile the terms, one is quadratic, one is a complete square, and the other one is a cube. Because x is always a positive number, those two terms will never be 0. You got no solutions there, and when you have no solutions, you can say that the curves don't meet, and then, but I didn't show that. So although I write that there are no solutions because I knew that it had to end that way, but I didn't give myself any marks there. All right. Number 9, I did this in like, I think 4 minutes, maybe, I don't know. So I was quickly integrating everything. So this is solid revolution. So the formula is the top line there is pi integral y squared dx, because I squared the, so I squared the y function inside my head and then put it there. And then because we are told that we should use substitution of tan u equals square root x. So yeah, and then I use, so this one is the identity of sec squared and tan squared, because sec squared minus tan squared is 1, so I rearranged and then got sec u squared to be 1 plus x. I put it here so it cancels with that, right? So I didn't quite take time to explain that properly during the walkthrough because I was running out of time. So I needed to quite rush through that. But anyway, I got this to be fine for part A. Got all the bounds correct. And then B was like the single last minute actually. So I substituted the bounds in. It got the answer to be 6 in the simplest form. So that was all fine. So the key here is, again, you are integrating into a third variable u. Yeah, because due to substitution, you need to do in terms of another variable. So don't forget to change the bounds, right? Because I've seen quite often people forget to change the bounds, and instead of the bounds for u, they have the bounds for x, and then that would make the whole thing wrong. You might be losing 2 or 3 marks, maybe, if you don't do that, right? So that's it for the feedback. So I hope that was all useful. If you have anything to say or comment, please feel free to do so. I'll try to reply to every comment. Please also check out other videos that I also walk through in other papers. And don't forget guys, keep studying. Bye!